Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we're going to talk about one of the new collections that we're introducing here in this chapter, and this is the set of buffers that exist in Scala.collection.mutable. So the idea of a buffer is, so we saw last time the inheritance hierarchy for these packages. It's traversable, it's iterable, it's a sequence. So in many ways, and the reason why I'm starting with the buffer here is because the buffer is the most similar to the sequences that we're used to. It's very similar to arrays and lists in that items are stored individually in order, and it's the ordering and the index that is how we keep track of things. So in many ways, these buffers are very similar to the things that you're already used to. So to help demonstrate this, we'll go ahead and we'll pull up Scala. Let's actually grow the window a little bit. Now, if I just try to make a buffer 5, 6, 7, the way that you would normally do this with like an array or a list, I run into an error. It doesn't know about buffer, and that's because by default the Scala collection mutable is not imported. And you have to realize that for a lot of these names, not the case of buffer, but for example, sequence, set, and map, there are two versions of them. Well, actually there's multiple versions of them, but there's at least two that are immediately obvious that we're talking about in this chapter. There's one that's in the immutable package, and there's another one that's in the mutable package. And those packages prevent them from being a name conflict, but they can't both be imported at the same time. And a standard style of dealing with this is to import collection.mutable. And if you want to use the longer form, import scala.collection.mutable. Now notice I didn't put ._. I didn't import all of the names inside of mutable. I just imported the mutable package itself. And the reason for doing this is that way in my code, when I'm making something that is mutable, I say mutable dot. This can be helpful, especially since, as we've talked about before, and we'll see more of this in future chapters, Scala pushes you towards a more functional style where you try to use immutable data. But if you're going to use things that are mutable, they want it to stand out. Okay, so it should be obvious that the stuff that you're working with is mutable data. Now, what does this give us back? It says that it's a mutable buffer event, and in particular, you'll notice that the type that was created is something called an array buffer. So this is not the only type of buffer. We could specifically create an array buffer. There is also a list buffer, and in a few chapters we'll talk about the differences. We'll go into detail about what it is that these list things that we keep referring to, how they're different from arrays, how they're stored, and what their strengths and weaknesses are. For right now, I'm perfectly happy using the array buffer, which is the default, and basically this uses an array in the background to store the values, but it can use an array. So for example, this buffer has 3 things in it. For all I know, this uses an array that has 10 elements or 20 elements or whatever, and it keeps track of the fact that I'm only using the first 3. Now because this is mutable, so let's go ahead and let's create another buffer. Commas. I need to give it a name. Buff equals that. Being mutable means that there's a few operations that we have here that we didn't have previously. Now, the standard operations, so for example, if I do a map on this, that res3 is not the same as my original buffer. My original buffer remains unchanged. All of the methods that you're used to, all of the methods that operate in a functional way and give you back a new collection instead of overriding the old one, they have to stay the same. And this is a significant aspect of the software design. you do not want to break this rule. If you are going to inherit from something, and because that's what's going on here, the buffer inherits from sequence, and then array buffer inherits from buffer. The sequence type, going all the way back to the basic Scala collection sequence, has a map operation. But that map operation has to work both for immutable and for mutable. And in the immutable, you cannot change things. Plus, it turns out that you would need to do this anyway, because in the case of map, you might be changing the type. So I'm not really allowed to, what I got back here was now a buffer of string. I couldn't have stored these contents, even though they look the same, but this 1, 2, 3, and 4 are strings, whereas the ones that are in buff are ints. And so I couldn't have used the same collection anyway. But the baseline is, the bottom line here is that all of the methods that you're used to calling continue to behave in exactly the same way. Okay? And you don't want to violate that. Otherwise, if a function were to take a sequence and you passed it one type of sequence, it might behave differently than if you passed another type of sequence. And that's very bad to have that happen in your software. So instead, there's a few other methods that are completely new, okay, that allow you to change your buffer. So, for example, I can append to my buffer, and you see now here I have a 7. And the thing is, this actually altered the value of buff, okay, the fact that it's mutable. And this is the thing that I couldn't have done with an array. Now, something that I could do with an array is do an assignment. I can do that same type of an assignment in a buffer, but in addition to the assignment, I can append. I can also, oops, let me put something here to prepend. Okay, so I can prepend to it as well. So plus equals adds to the end, plus equals colon adds to the beginning, and notice the order here. When you're appending, because the operator does not have a colon, you wind up adding it. It goes in the proper order. The thing you're adding is on the right side of the value, and it appears over on the right side, whereas here it appears on the left. Remember that operators that have the end in a colon are considered to be left associative instead of right associative. So they bind with the object that's to the left of them instead of the object that's to the right of them. I guess it's also worth pointing out that this is the same as plus equals colon 15. Of course, now I'm going to have another 15 in there. Buff dot remove 0. I want to get rid of one of those 15s. So there's a remove method which will actually take things away. And you don't have to take it off just from the beginning. So if I wanted to remove the 2, which is now at index 2, I can do so there. Okay. So buffers in some ways are your ultimate mutable sequence. You have the ability to add to them, you have the ability to remove from them, and your adding can be at the beginning or the end. There is also an insert. So see if I can remember if I have those wrong, I'm going to get an error here. Nope. Okay. So it takes and it inserts a new element at the first one's the index, and the second one is the value. 0, 1, 2, 3 is where the 6 went, and the 4 and the 7 got pushed down by doing this. There should probably also be a buff dot insert all. Let's put these at 2 and pass it the list 987. Now if you look at buff, starting at index 2, 987 now appears, and everything else got pushed around. So So hopefully you can see the basic capabilities that you have with your buffers. If you have something where you're doing lots of adding and removing from it, and especially if you have to be generally adding and removing, a buffer is probably the way to go. But you have to keep in mind it is mutable and it's going to have some of the downsides of that. We'll come back in a later video when we start using this in the project, and you might remember from the project code I put in a whole bunch of these var lists. I'm going to get rid of all of those var lists and change them all to buffers. And instead of being var lists, they will be val buffers, because now the reference doesn't have to change. It will be the mutable object that changes instead. So that's it for this video, and hopefully now you understand buffers, and we'll see you again soon to talk about sets.